I'm Dr. Paul Mason, and this is the moon in a nutshell. And this is our typical view of the moon, specifically the full moon at sunset, about to happen over the mountains here. And we keep in mind that to see a full moon, the sun would have to be in the opposite direction of the moon. So sunset happening in the west, this moonrise of the full moon is in the east. And so the full moon is what we see here. Now, from space, this from 1,000,000 miles out in space, photographed, series of photographs taken by climate studying spacecraft, observed the moon and the earth here where the moon transits across the earth. And you can see the back side of the moon. This is the lit here from the sun from behind. We can see the subsolar point. This is the bright spot on earth indicating where the sun is. The sun is right behind the viewer here. And this part of the moon we never see from Earth because the moon rotates synchronously around the Earth, so that we only see one side, and this is the back side, the part that we usually don't see. Now notice the back side here, we can see even here, doesn't have a lot of the dark features. One in particular there, but not a lot of the dark features we're used to seeing on the near side or the front side of the moon. So Galileo was the first to observe the moon through a telescope and mentions the fact that the moon is not a perfect sphere like Aristotle had thought. The moon is covered by mountains and craters and is a interesting place, not necessarily unlike the Earth. And this was added to the controversy of the heliocentric versus the geocentric model at the time. So we see here now, looking at the near side of the moon, all of these features are labeled here, and we see two basic types of terrain: a bright, heavily cratered highlands, and this is an orthosite rock. It's very low density. And then the darker lowlands, they're lower down in altitude, and they are from the darker lava flows that occurred and in the past. And so those are called maria, and we can see craters on both parts, but the maria are much smoother because the lava that flowed in here filled in all of the previously existing craters, and only impacts occurring after that are seen in the darker maria areas. However, the highlands show the full impact history of the moon, and over about 4.5 billion years. And so there are impacts here that are very old, and then some newer ones. One of the newer ones here is the Tycho crater that shows these rays coming off right into the highlands here, and the Copernicus crater, which is more in this area where the Mare are, is something I'll also mention and talk about, those two. And so there are relatively new craters. So the Copernicus impact crater over here, up close looks like this, and we can see this shape, roundish shape, and we see the what's called the central peak. And many of the craters on the moon have a central peak, and this is because they thought that when an object came and made this impact, was much smaller than the size of the crater itself, and it melted the entire region of the crust, and as it came down and hit, the central part came up and kind of flowed upward as everything moved out, and then flowed back in and flowed up, and then cooled suddenly as the mountains there in the center. And so we see this on many of the craters on the moon. So the other crater I'd like to mention is this Tycho, and we can see it as these bright regions all the way across, these bright rays that go very far across. So this is ejecta flinging out from far away from the crater. We can see the crater more closely here without seeing the rays as well. And we see the central mountains, the central peaks here as well, of a very up close image to see that they're very mountainous looking at the very center of the Tycho impact crater. So we always see the same side of the moon or the same face. The moon originally rotated faster than it does now, but ever since its early stages in its history, its rotation slowed down, mostly in the early stages, and the spin of the moon became tidally locked to its orbit around the Earth. And this is because the gravity of the Earth is very strong, and the moon, originally spinning very quickly, was not perfectly symmetrical as a sphere. And it's thought that maybe the darker areas are a site of impacts here that made the moon heavier on one side and caused the moon not to be symmetrical. And this, as well as its not perfectly circular orbit and these things, cause the tidal effects to be very strong, rotating the moon around so that the rotation rate, the spin rate of the moon ended up being the same as the orbit of the Earth, of the moon around the Earth. And if we look here at the interesting thing that nobody ever saw before the spacecraft first were able to orbit around the back side of the moon and see what it looked like, that there is a very big difference. We see the Maria are mostly on the front, very few on the back, very heavily cratered regions on the back that look a lot like just the highlands on the front. And so the moon is the only world beyond Earth, of course, to be visited by humans, and only 12 people have visited the moon. And one of the things that they found is the moon rocks, bringing back moon rocks. We're able to analyze those here on Earth, and so it's the only object in the solar system that we have the ability to analyze, bring back and analyze the rocks that are there. It's the only one that we've been able to do that so far. On Mars, we were able to go and study the rocks on the surface, but not bring them back. There are quite a few moon landing sites we can see here, both the Lunar and the unmanned, and then the Apollo manned landing sites. Ice exists at the bottom of craters near the South Pole. Here's a picture of the South Pole, and there is the South Pole Aitken crater. That is a very large crater near the South Pole. And at the bottom of various craters at the South Pole of the moon, something similar that we have on Mercury, and that is that ice exists at the bottom of the craters that never see sunlight, and so the ice never melts. So as far as the structure of the moon goes, we probably have a core that is a inner core and a liquid outer core and a partially melted region around that, and and then most of the rest of it is solid, a mantle and a thin crust on top of that. And so really that is the moon in a nutshell.